Introduction: launching rockets into space is a fascinating yet complex process, influenced by a variety of scientific and one common and strategically important practice is to launch rockets eastward. This direction is not chosen randomly but is based on specific benefits that make space missions more efficient and safer. In this video, we'll explore why space rockets are launched eastward. 1. Leveraging Earth's rotation. 1.1 The speed boost. The Earth rotates from west to east, completing one full rotation every 24 hours. At the equator, this rotation gives a speed boost of about 1670 km per hour, 1040 miles per hour. When rockets are launched eastward, they can take advantage of this rotational speed, effectively getting a free ride that helps them reach the necessary speed for orbit more efficiently. 1 point to adding to orbital velocity. To stay in orbit, rockets need to achieve a high velocity, typically around 28,000 km per hour, 17,500 miles per hour. Launching eastward means rockets start with the Earth's rotational speed already added to their own speed. This reduces the amount of fuel needed to reach orbit, making the launch more efficient. 2. Fuel efficiency and cost savings. 2.1 Reduced delta-v requirements. Delta-v is a term used to describe the change in velocity a rocket needs to perform maneuvers, like reaching orbit. Launching eastward reduces the delta-v required because the rocket already has some of the needed velocity from the Earth's rotation. This reduction in delta-v means less fuel is required, which lowers the cost of the launch. 2.2 More efficient staging. Rockets are usually built in stages, each of which is jettisoned once its fuel is spent. With the savings from the eastward launch boost, each stage can be optimized for better performance, enhancing overall fuel efficiency. This allows rockets to carry heavier payloads or achieve higher orbits with the same amount of fuel. 3. Safety and risk management. 3.1 Over water launch trajectories. Many spaceports are located near large. Launching eastward often means the rocket's trajectory is over the ocean. If something goes wrong during launch, the debris is more likely to fall into the water rather than populated areas, minimizing the risk to human life and property. 3. Range safety protocols. Space agencies have strict protocols to ensure that rockets can be safely destroyed if they go off course. Eastward trajectories over the ocean provide a clear path, making it easier to monitor and, if necessary, safely terminate the flight to prevent accidents. 4. Historical and geographical factors. 4.1 Equatorial advantage. Spaceports near the equator, like the Kennedy Space Center in Florida and the Guiana Space Center in French Guiana, are ideally positioned for eastward launches. The rotational speed of the Earth is greatest at the equator, providing the maximum possible boost to rockets launched in this direction. 4.2 Historical precedents. During the early space race between the United States and the Soviet Union, both countries developed spaceports and infrastructure with eastward trajectories in mind. This historical precedent has influenced subsequent space programs and contributed to the continued preference for eastward launches. 4.3 Infrastructure and logistics. Developing spaceports and launch infrastructure is costly and complex. Many spaceports were initially designed for eastward launches, and adapting them for different directions would require significant investments. It is more practical to continue using existing facilities optimized for eastward launches. 5. Case studies of eastward launches. 5.1 NASA and the Kennedy Space Center. Located near the equator, the Kennedy Space Center takes full advantage of Earth's rotational speed. Most of NASA's launches, including those of the Space Shuttle and the Artemis program, are conducted eastward over the Atlantic Ocean, minimizing risks to populated areas and maximizing fuel efficiency. 5.2 European Space Agency (ESA) and the Guiana Space Center. Situated just 5 degrees north of the equator, the Guiana Space Center is ideally positioned for eastward launches. The European Space Agency and commercial partners like Arianespace conduct launches from this site, benefiting from the equatorial boost and the safety of over-water trajectories. 5.3 SpaceX and the Falcon 9. SpaceX frequently launches its Falcon 9 rockets from Cape Canaveral, Florida, next to the Kennedy Space Center. These eastward launches, especially those for geostationary transfer orbits, leverage the Earth's rotational speed for efficiency and cost-effectiveness, contributing to SpaceX's success. Conclusion: in summary, launching rockets eastward takes advantage of the Earth's rotational speed to provide a significant boost, making the process more fuel-efficient and cost-effective. Additionally, eastward launches often have safer trajectories over water, minimizing risks to human life and property. Historical precedents and geographical advantages further solidify the preference for this launch direction. By leveraging these factors, space agencies and private companies can optimize their missions, making space exploration more feasible and efficient. Thank you for watching. If you